Lesson 69 is going to combine gas law problems with scientific notation. So our gas law problems, ideal gas equation was P1 V1 over T1 equals P2 V2 over T2. P is pressure, V volume, T is temperature. Well, I'm going to skip part of this word problem real quick and fast forward to the end. The end says solve for P2 first. So what it wants us to do is get P2 isolated and by itself. Well, the easy way to do that in this case, you could think of it as multiply by T2 and divide by V2. But if we multiply by the reciprocal here, T2 over V2, well, these cross out. We do it to both sides and get T2 over V2. So now we have solved for P2 and we can plug everything in. But that's all that is. That's all you're looking to do. That's easy. Nothing to it. Now let's look to plug in what we know. It says a quantity of an ideal gas had initial values of 0.003 times 10 to the 14 pound inches per inches squared, 0.007 centimeters cubed, and 7,000 Kelvin. Find P2 if the final volume was 3 times 10 squared centimeters cubed, and the final temperature was that. Okay, so which one is this? Is this pressure, volume, or temperature? Well, temperature, if you don't know like your measurement stuff and which one it would fall under, well, you can look at other keywords. It says temperature was this kelvins, so we know temperature is kelvins. So this is T1, this is T2, and then it says find P2 if the final volume was 3 times 10 centimeters cubed. So this is our final volume, so this is V2, making this V1. Leaving us, well, we're solving for P2, leaving us with P1 right here. So we plug these in. I'm going to write 0.003 times 10 to the 14th. Okay? Doesn't matter which order these are in. I put the P1 first. It's all the same when it's multiplied. What's our temperature 2? Okay, our temperature 2 is times 0.003 times 10 to the 7th. Did those two? What's our volume 1? Right here, times 0.007. I don't need my measurement. There's 0.0, there's 3 zeros. No, that's me. 0.0007. And then we have our volume 2. So all this is in the numerator, and our volume 2 is 3 times 10 squared, leaving our temperature 1 of 7,000. And all this equals P2. Now, rather than solving manually, we're going to do this with our handy dandy calculator. So I'm going to help you put all this in. I'll try my best to be, let me try to come on this side to where you can see what I'm plugging in my calculator and see the problem. So I'm going to plug in on the top. I need to do a double parentheses like I showed in the last lesson. Double parentheses, and I'm going to punch in 0.003. Remember, times 10 to the whatever power, we do second, comma, and that's that EE button. So right now your calculator should read parenthesis, 0.003 E, and then I put 14, close parentheses, open parentheses, 0.003, and this is times 10 to the 7th power, close parentheses, open parentheses, 0.0007. It's trying to trip us up with all the zeros. Now, since this is the last set of parentheses, I'm going to put a double parentheses around it. to make sure it doesn't confuse our order of operations, then divided by double parentheses again on the bottom, that's key, 3, and then it's times 10 to the second power, close parenthesis, open parenthesis, 7,000, double close parentheses, hit enter, and I get 3 times 10 to the 6th is how that would be read. 3e to the 6th is 3 times 10 to the 6th. And so I write that they got 3 times 10 to the 7th. I must have typed something in wrong somehow, but this is close enough. P2 equals 3 times 10. I'm going to go ahead and put to the 6th. I must have missed a 0 or something. Yeah, I see where I missed it. I think I put too few zeros on the 3. Anyways, I'm just going to show you the answer here. I think you got the idea. What is our measurement? Pounds per inches squared. And that is how you solve gas law problems when you have scientific notation within them. Sorry that I punched in a wrong number somewhere, but you get the idea of how to do it. Anyways, that is all that we're going to do in lesson 69. One example, I think you got the idea.